After winning $50,000 by playing bingo, Mildred gave $10,000 of it to her grandchildren. She invested part of the remainder in a growth fund that earned 4.2% annually, and the rest in a CD paying a 5.5% annual percentage yield. The interest that she received on these two investments totaled $2,005 at the end of the first year. Find the amount of each investment. We need to start with our let statements. What should our let statements be? Since they're asking us to find the amount of each investment, we'll let the amount invested in the growth fund be X and the amount invested in the CD be Y. Next, we need to make a table to organize our information. What relationship will we use to set up the labels for our table? The relationship is principal times rate equals interest. Great. Now on the left-hand side, we need to label the two rows. The two accounts we have are the growth fund and the CD. So we can label those two rows as growth fund and CD. Sometimes students, instead of using the names to label them, use the percentages. We've got the 4.2% account and the 5.5% account. That's also an acceptable way to differentiate the two accounts, but I'm going to use the names of the accounts here. Now we need to start filling in the table. We're going to start here. What is the principal amount that was invested in the growth fund? We aren't given a dollar amount for how much was invested in the growth fund. That was actually one of the unknowns, and so we made a let statement. We decided to let the amount invested in the growth fund be X, and so that means the principal for the growth fund is X. Similarly, the principal for the CD is Y. Now we need to fill in the interest rates. We know the interest rate for the growth fund is 4.2%. What are we going to fill in the table here then? We always need to convert these to decimals, and 4.2% as a decimal is 0.042. Similarly, for the CD, we're going to have 0.055 because that interest rate was 5.5%. Now, for the last column, for the interest column, we need to multiply the entries in the first two rows because when we take the principal times the rate, that's equal to the interest. So for the first row, X times 0.042 is 0.042X. And then for the other one, Y times 0.055 is 0.055Y. Now that we've filled in everything in the table, we have two pieces of information that we need to put on the outside of the table. Generally, on the bottom, we put the total principal and then the total interest. What should we put for the total principal, which means the total amount that was invested between the two accounts? Now this one's a little tricky. Some students might want to put $50,000 there because that's how much money Mildred won in bingo. But remember, she also gave $10,000 of it to her very lucky grandchildren. And so there's only $40,000 left for her to invest. So the total principal is going to be $40,000. We're also told the total interest earned after that first year was $2,005. So that's going to go at the bottom of the interest column. Now that we've made our let statements and we've filled out everything in the table, organizing all of our information, we need to write a system of equations that models the situation. The first equation is going to come from the first column. What equation does this column give us to solve? Here we know that x plus y has to equal 40,000. Remember, we don't know how much was invested in each of these accounts, but whatever those two quantities are, we know that the total was 40,000. So that means that x plus y has to equal 40,000. Maybe it's 20,000 and 20,000, maybe it's 30,000 and 10,000. We don't know the individual amounts, but the sum has to be $40,000. Similarly, in the interest column, we get another equation. That's going to be 0.042x plus 0.055y equals 2005. Again, we don't know how much interest was earned in each individual account, but we know that when we add them together, the total interest is $2,005. So that's what this equation represents. Now we have our system of equations, and so we're able to solve it. I'm going to use substitution to solve this system of equations, and I'm going to isolate x here in the first equation because it doesn't have a leading coefficient that we're going to need to divide by. It's an easy variable to get alone. What do we get when we isolate x by itself in this equation? To get x alone, we need to subtract y from both sides. That's going to give us the x alone on the left. And then on the right-hand side, when we subtract y, we've got 40,000 minus y. And then once we have that, we can substitute that in. Wherever we see an x in the other equation, we can replace it with 40,000 minus y. So that gives us 0.042 times 40,000 minus y, we made that substitution there, plus 0.055y equals 2005. By making that substitution, we now have an equation that only has one variable, y, in it, so we can solve for y. What's the next step here? If we want to get y on its own, we're going to have to get rid of the parentheses, and we're going to do that by distributing the 0.042 into both of those terms. 0.042 times 40,000 is 1,680. We can get that easily from a calculator. Minus 0.042y plus 0.055y equals 2005. Next, we can combine like terms here. We still have the 1,680 out front. What do we get when we combine the two y terms? When we combine those coefficients, we end up with a positive 0.013y, still equal to 2005. If we subtract 1,680 from both sides, that leaves us with 0.013y equals 325. And then if we divide both sides by 0.013, we end up with y equals 25,000. So since we learned that y equals 25,000, what does that tell us about the situation in this problem? Because y represented the amount invested in the CD, we know that Mildred invested $25,000 in that CD, or certificate of deposit. So now that we know how much she invested in the certificate of deposit, we need to figure out how much she invested in the growth fund. There's two ways of doing that. We can use a little bit of logic. Remember, she had $40,000 to invest in total. If she put $25,000 in one account, that leaves $15,000 in the other account. Or if we want to do it more mathematically as far as the system of equations goes, we can go up to this equation, x equals 40,000 minus y. We know that y is 25,000, so we can take 40,000 minus 25,000, and that gives us the same 15,000 that we had before. So for our final answer, we were asked to find the amount of each investment. We can say Mildred invested $15,000 in the growth fund and $25,000 in the certificate of deposit, or CD. And that is our final answer.